good morning, I guess, good evening, wherever you are. So the world of software architecture has evolved. Back in the day, you would have all the software needed for a company hosted on one server, mainframe. And slowly, we moved into what I call as distributed architecture. And now, I believe we are in what I call as a connected architecture, where you have organization A using an application hosted by organization B, and that in turn uses services from organization C. In real life, actually, this chain could be much bigger than just three organizations, or it could be three different departments or teams within the same organization. The point here is dependency. Now, we just heard about DevOps from our keynote speaker, right? So, with concepts like DevOps, CI/CD, we're transitioning into what I call as a conveyor belt style software delivery. And with cloud-based systems, the first thing we learn from a design perspective is build resilient software, resilient to all failures as far as possible. Now, when you bring all of these concepts together, you might wonder, how can I survive without simulated test environments? And that's exactly what I'm going to share with you today. How PSU plans to optimize delivery with simulated test environments. Or in other words, how we at PSU had this aha moment. All right, so a little bit about me. I'm currently at PSU. I'm responsible for the architecture, design, delivery of the API platform. PSU has adopted an API-centric approach, and that means APIs are being used in almost every nook and corner within PSU. I have more than 20 years of experience, 20 plus years of experience building and leading cross-functional global teams. I started my career as an application developer and moved into architecture. I have architected solutions both using on-prem data center-based solutions as well as cloud-based solutions, Azure, AWS, Google Cloud. Now, in the early stages of my career, I was in the insurance domain, but more recently, I have been in the financial domain, and of course, with PSCU in the retail banking and credit cards or card data. All right, so here is a quick look at the agenda. I will cover more about PSU in the next slide. Now, as you can see, we'll go through the challenges, what I call as the aha moment that we had, and our current and future plans to evangelize service virtualization within PSU. Now, as you look at, these numbers, I'm going to share, here's a quick intro on PSU itself. So PSCU is a credit union service organization. It offers technology products and services, as well as business process outsourcing and other business advisory services to credit unions across North America. Of course, with the eventual goal of crossing those geographical boundaries. Essentially, we are a fintech organization for credit unions. Now, we are also growing. We are expanding. We are expanding our customer base to include community banks in addition to credit unions. And we are going to be offering them the same services through the brand name of Primax. So PSU, credit union, Primax, community banks. Now, PSU has grown, expanded very quickly over the last few years. We have acquired companies. We have entered into new partnerships to become one of the leading financial, the fintech organization for credit unions. As part of this expansion, we have acquired many companies. So I'm going to talk about a few of them. Lumen Digital, acquired in 2018. Lumen provides cloud-native digital banking solutions to credit unions across the United States. Amount, a recent partnership. Amount provides a cloud-based lending, origination, and account opening solution to some of the nation's top banking clients. And so PSU will customize this offering and offer it to the credit unions and community banks. Juniper Payments, also a recent acquisition in May 2022. Juniper enables PSU to expand into real-time payment capabilities. So think Zelle. Now, Juniper also provides managed connectivity to Fed Reserve, the clearinghouse, and the FedNow service, which is coming up as well. All right, so here is a quick look at the wide array of solutions that PSU provides. Now, just note that most of these solutions are essentially software as a service, SaaS offerings, technology products, software hosted by PSCU. And a few others are essentially business services, business process outsourcing, as well as the business advisory services. And you can find all of this information on pscu.com if you go to that website. So the API platform, this is my wheelhouse. So I am responsible for managing and maintaining, not from an operations perspective, but from a architecture, design, delivery perspective, this platform. So we have over 400 APIs, and this number keeps on increasing. Now, these APIs are, at this point of time, used primarily by our SaaS offerings, but we have plans to expand this usage so that the credit unions and community banks can directly suffice their data needs by using our REST API platform. And we continue to grow this API portfolio through partnerships with companies like Amount that I just mentioned, Juniper Payments, Visa, MasterCard, and others in the fintech space. Now, as you can see, on the diagram there, APIs expose both internally hosted data as well as internally hosted, as in hosted within PSU, and third-party data. And this third-party data source is our biggest challenge, as we uncover in the next few slides. On the left-hand side, you can see the API offerings, and this is, again, just a snapshot of those offerings. We offer, many APIs in the card management, retail banking domain. Now, this picture might look scary, and that was the intent, but don't worry. What you see inside those dotted lines represents what's inside PSU. And what's outside is what I label as third-party data providers or partners. Now, the yellow boxes towards the bottom represent the banking cores, and the purple boxes towards the right are, essentially card data, credit card, debit card data hosted by Pfizer, First Data, chose First Data. And that is where lies the challenge, the number of boxes that we have outside of PSU. And this is a good segue into the next slide, where I talk about challenges, or what I call as the aha moment as well. So I'm going to talk about 3 challenges today. The first challenge, testing in production. Now, if we are truthful to ourselves, I'm sure that at some point in our career, we have done this. We have tested in production. I'm sure I'm not the only one. And I have seen many memes about this topic. But memes aside, this is a scary situation. When we in PSU discovered, when we rolled out a new version of our APIs that was going to impact over 100 of our customers. Now, we literally had to discover these issues in production, one credit union at a time, fix it without the ability to test that specific fix and deploy to production, and rinse and repeat for the next one. Now, you might naturally ask, why did we have to do that? Well, because our test environments provided by third party did not have all the customizations that these credit unions had in production. And this rollout, just from a production rollout perspective, leave alone all the development and the QA testing, that production rollout took us a year to implement. Now, if we had service virtualization, I bet you we could have wrapped that production rollout in a month or maybe a max 2 months. Now, rollback of a flagship SaaS product. So we have a SaaS offering, which is used by our tellers across our customer base, 1,900 credit unions. We had an Angular upgrade to that product, and we had to roll it back because of our performance, we encountered performance issues in production. Of course, we fixed the issue and, moved forward. The point is, we had done performance testing. However, our performance testing was, I would say, inadequate, because as we soon discovered, our backend providers throttled our request when we did that load testing. Now, last but not the least, failed builds. So we implemented Sonar Cube to measure our code quality on our API platform very recently. And there were 2 aspects that we look for: static code analysis and code coverage. So with code coverage, we found that with the current test environment that we had, in some cases, we could not go beyond 30%. I would say that is, pathetic from my perspective, because we could not create all the scenarios required. And so all of this kind of came together into what I call as the aha moment. And we realized service virtualization is the only path forward. And so that's why, here I am talking about, why service virtualization. So as you can see, I have shared how service virtualization is going to benefit different teams, the dev team, the SQA team, the performance team. I'm not going to go through all the details here, but from the dev team perspective, the code coverage or achieving a higher percentage of code coverage was really the benchmark that we wanted to achieve. The other part was, we have a CI/CD pipeline, and we don't want the CI/CD pipeline to be dependent on something external. The SQA team, the biggest benefit for them is they are able to test those difficult to execute scenarios or impossible to execute scenarios, I would say. And the other aspect of this is the ability to precondition the data. Now, at this point of time, if you want to precondition the data, you have to go in, log into the third-party system, do a bunch of stuff. With service virtualization, it would be flick of a button. Now, the performance team, the same benefits as the SQA team, but the main point that they would be looking for is eliminating the inconsistent backend latency. All right, so as I go into the next few slides here, we, as in within PSCU, adopted service virtualization very recently, and we decided that we better crawl before you walk, walk before you run, and that's why we focused on, let's start small. Let's start with a developer only usage, and that's what I'm going to share in the next few slides, next two slides. But the slide following that, we will be covering how we plan to adopt service virtualization across PSCU. That includes the QA team, the performance testing team. Now, from a infrastructure layout perspective, as you can see, we have a virtual asset server, we have a continuous testing platform, and we use Bitbucket, by the way, to store our source code, and we are planning to store our virtual assets within our Bitbucket repository as well. The QA and the performance testing teams will continue to use the external third-party components at this point of time. And this shows really a curtailed view of our SDLC workflow for API development. The main point here is that the development team is responsible for creating the virtual asset and revising it if needed. I mean, we have not encountered that situation yet because we are still in the process of, early stages of creating virtual assets. But pretty soon, I'm sure that we will end up recreating versions of the virtual asset as well. So PSU-wide usage. This is our target. This is where we within PSU want to be, so that all the teams, not just the development team, the SQA team, the performance testing team, also start using service virtualization. And so this is a snapshot of what we anticipate the infrastructure to look like. Now, this slide shows that we will have a virtual asset server for the development team, for the QA team, for the performance testing team, and I'm sure that Parasoft would love that idea from a sales perspective, right? But more than likely, as we take the next step, we are most likely going to combine the dev and the SQA teams so that they can use the same virtual asset server. And based on the need, at some future point in time, we might expand that. Now, here is a look at, again, a small section of the workflow, the SDLC workflow, once we move into a PSU-wide usage. The main point to focus here is on the test data management team. We do not currently have a test data management team. At this point of time, if there is test data that needs to be created in the real world, in the real test environments, we have folks within the QA team that manage that, create those preconditioned test data. But my vision is, or this is how I envision it, we carve out a separate test data management team that is responsible for not just creating test data in the real world in the third party test environments, but also create the virtual assets, the virtual test environments. And then all the other teams, the development team, the QA team, the performance test team, can just use those virtual assets as part of their unit testing, as part of their QA testing and performance testing as well. So this is our vision. Now the structure of the team needs to be thought through. We need to put some discussion around it. We are not there yet, but that's the vision. Now the obvious question is, why Parasoft? Why did we choose Parasoft? Now, truth be told, there are several vendors out there in the market that offer service virtualization, and we did do our due diligence, by the way. We found that there are a few products that are extremely cost prohibitive, some of the larger vendors, and others are relatively unknown or limited in scope. So Parasoft offered the right mix of affordable balance of cost and the base features, which is the protocol coverage that we needed from a PSCU perspective. And of course, I cannot talk enough about their technical support that they provided during before the onboarding, when they were doing a demo, as well as after the onboarding. So it made natural sense for us to go with Parasoft. Now this is our target, something that we aim to achieve: improve quality, reduce time to market, improve code coverage. Now from the code coverage perspective, we are currently at 30%. Actually, we might be at 50%. We just bumped it up recently. But our target is to achieve 80% or even beyond. And improving quality, KLOC, by the way, KLOC stands for thousands of lines of code. It's a traditional measure of how long large a computer program is. And 0.5 KLOC is Microsoft's benchmark. There is half a defect every 1,000 lines of code. So, we said, if you want to aim, why not aim high? And so that's why we are targeting 0.5 KLOC. Ultimately, with improving quality, improving code coverage, we aim to achieve a reduced time to market. Now that brings to the end of my presentation, and I'm sure that you have heard about the concept of mock testing, as well as using test stubs. So I think service virtualization is nothing but an evolution in that context. And so I have provided my contact details on the left-hand side of your screen. You are welcome to connect with me, contact me if you have any questions. I hope that this presentation provided you with what you needed from a service virtualization perspective. I'll be more than happy to connect with you offline, and I believe we may have some time for questions at this point.
All right, yeah, thanks, Hirikant. We did have a question around the service virtualization as an enabler for code coverage. Like, have you been seeing improvements in your coverage?
Absolutely. So, one of the first challenges that we had, dealing with the banking course, we had to literally test in production. And now that we have service virtualization, we, whenever previously I used to get the comment, hey, sorry, we cannot create this scenario. We cannot go beyond 30%. Can you please give me an exception? And now they do not come to me. It's like we have evolved into this whole different world where we are not dependent on what happens outside of PSU. Not that we will ever be in that case, but essentially we are, I would say, self-dependent.